This is the question. First, I will explain the question. So at time t equal to 0, the switch is closed. Before closing the switch, that is, when the switch is open, these two capacitors acquired some initial voltages. That is, these two capacitors are charged to some initial voltages. The C1 is charged to V1. This is the initial voltage when the switch is opened before closing the switch. This is Vc1 0 minus. That is, initially this capacitor is charged to V1 and C2 capacitor is charged to V2. Right? Then the question is, after closing the switch and for time t greater than 0, for any time t greater than 0, what is voltage across the capacitor? Function of time. What is voltage across the capacitor C2? That is Vc2t. That is function of time. And also he asked the steady state values, that is Vc1 infinity, Vc2 infinity across these two capacitors. This is the question. So I will explain how to tackle this type of questions. So usually this type of circuit is called the tank circuit. Okay? So I'm drawing the circuit for t greater than 0. Okay? So when t greater than 0, the switch is closed and this is the resistor C1, C2. Right? C1 and C2. But at t equal to 0 plus, it is immediately after closing the switch. What are the voltages across these capacitors? We know that these capacitors do not allow sudden changes in voltages. This is the property of the capacitor, right? So whatever the voltage present across the resistor before the switching action, that is at t equal to 0 minus, the same voltage will be present at t equal to 0 plus. It is given V1, and Vc2 0 minus is same. Vc2 0 plus is V2, and in the question he has not mentioned anything about these V1 and V2 values, that is which is greater, which is smaller. I am assuming that this V1 is greater than V2. This is the assumption. Okay? You can assume V2 greater than V1 also. So in this question, if V1 is greater than V2, that is V1 is present here initially at t equal to 0 plus, right? I am talking about at t equal to 0 plus. Initially here we have V1, here we have V2, right? Voltage across the capacitor C1, voltage across the capacitor C2. So what happens if this kind of situation is there? And I am assuming V1 is greater than V2, right? If this is the condition, then what happens? The current flows in this direction. The current flows from higher potential to lower potential. This is V1. This is V2. At t equal to 0 plus, I'm talking about all these things. Okay. So at t equal to 0 plus, what's happening here? Here it looks like this capacitor C1 is here, current is entering at C1. Here current entering at C1, C2, same current. Right? So here the current enters at negative terminal at C1, right? The positive and negative, it enters at negative terminal. But here at C2, current enters at positive terminal, right? If current enters at negative terminal, which means this is delivering power. If the current enters at a positive terminal, that is this capacitor is absorbing power, right? So In this case, at t equal to 0 plus, the, the C1 capacitor is delivering power to the this resistor, the voltage here I into R, right? And here V2. Okay. So how much time it will deliver? Because it is not an active device to deliver from uh, infinite time, right? It is not active device. This capacitor C1. This is passive device. So because of this, that some initial voltage, it has some stored energy, right? Because of that energy, it is supplying power to the circuit. So after some time, that stored energy will get dissipated. How much time it will take? That is the question. So this current flows or this C2 capacitor charged up to how much time means when these two voltages gets equal, right? So here it has V1 initially at t equal to 0 plus this is V1, at t equal to 0 plus this is V2. So for t greater than 0, this is supplying power to this and this capacitor keep charging. This capacitor C2 keep charging and this voltage is increasing. V2 plus some value adding. With respect to time, it is increasing, right? So up to which value it will be increased when this V1, right? This let us say at some time t, this is VC1t. Okay, otherwise I will draw here. Next slide. Initially V1 is there, here V2 is there at C1 and C2. This R. Initial voltage is V1 and this is V2. Let us say at time t greater than 0, some time t, this is plus minus Vc1t is there. Here plus minus Vc2t is there for time t greater than 0. If t tends to infinity, that is when they reaches to infinity, this when they reaches to steady state, then what happens? So this will deliver power to the circuit or this capacitor absorb power from this capacitor. The C2 capacitor absorb from this capacitor up to some which value. So here the voltage of C2 is keep increasing plus some value, right? Keep increasing. Here voltage of capacitor C1 V1 is keep decreasing, right? Up to certain value. So how much voltage is decreased at capacitor C1 and how much voltage is increased at capacitor C2? At infinity, they will acquire equal voltages. When this is V1 decreased, 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 and we assumed V1 greater than V2, at some point of time it gets V2, that V1 equal to V2. These 2 points, if this V1 equal to V2 at some point, then what happens? The current flows in the circuit is 0 amps, right? Up to that point, the C1 capacitor will charge the C2 capacitor up to these two capacitors get same voltages, is V1 equal to V2. Okay. So this is the concept. So I want to give you how to tackle this type of problem. Okay, that I will explain the next slide. So here we have the circuit. This is C1, this is C2. I want to write VC1T in terms of T. VC2T, this is R. So I am assuming V1 greater than V2, initial voltage of C1 greater than initial voltage of C2. So the current flows in this direction. So the capacitor C1 keeps decreasing its voltage and the capacitor C2 keeps increasing its voltage up to at a steady state these two voltages gets equal. Up to that time, this current will flow in the circuit. Okay, so I want to write these voltages of Vc1t and Vc2t in the function of time at any time t greater than 0. So Vc1t is equal to, initially it has V1 initial voltage, that is Vc10 plus, and for t greater than 0 this value is decreased, V1 is decreased, that is minus, that is why I'm putting minus here. And the net voltage here, this is V1, here this is V2 at t equal to 0 plus. The net voltage is V1 minus V2 into the, we are calculating at C1, right? So V1 minus V2 into opposite capacitance C2 by C1 plus C2 into 1 minus e power minus t by tau. This is the formula, right? This is how we have to remember this. And I will write Vc2t. But in case of Vc2t, C2 is keeps increasing its voltage because it is acquiring, it gets charged by this C1. Initially it has V2, right? And this voltage is increasing here, that is why we are putting minus. And the net voltage initially is V1 minus V2 into, what is the capacitance we have to put here? Here we are calculating at C2, so opposite capacitance C1 by total capacitance C1 plus C2 into 1 minus e power minus t by tau. This is how we have to remember the formula. Next, what is tau here? That is also important. This is R, this is C. After closing the switch, this is C1, this is C2, this is R. Tau equal to R equivalent, C equivalent. R equivalent is only R is here. C equivalent, these two are in series, right? The same current. These two are in same series. C equivalent, in case of series combination, C1 C2 by C1 plus C2. It, right? This is how we have to remember. And I will derive the formula for steady state values. He also asked in the question, what are the steady state values? So for that, Vc1 infinity, Vc2 infinity. I already told you how to write these equations. First equation, that this is the direction of current. According to the direction of current, we have to write the direction of current is decided by which initial voltage is greater. Here I am assuming the voltage at capacitor C1 is greater. That is why the current direction is like this. Now Vc1t is V1 minus, because it is delivering power, this its voltage gets decreased, V1 minus, and the net voltage is V1 minus V2. We are calculating at C1, that is why opposite capacitance by total capacitance, 1 minus e power minus t by tau. And Vc2t, here the capacitor C2 is absorbing power, net voltage V1 minus V2 into C1 by C1 plus C2, 1 minus e power minus t by tau. Okay, and we need to calculate steady state values. So if you want to calculate steady state values, put t equal to infinity here. So Vc1 of infinity, what you get here, put infinity, you will get 0. So V1 minus V2 into C2 by C1 plus C2. Calculate this. V1 C1 plus V1 C2 minus V1 C2 plus V2 C2 over C1 plus C2. These two gets cancelled. Now V1 C1 plus V2 C2 by C1 plus C2, right? Now calculate Vc2 of infinity. Vc2 infinity. Here t tends to infinity. You will get 0. This is 0. This is also 0. This term becomes 0 if t tends to infinity. Then we will get V1 plus V1 minus V2 into C1 by C1 plus C2. That I will write here. Vc2 of infinity V2 plus V1 minus V2 by C1 plus C2 into C1 V2 C1 V2 C2 V1 C1 minus V2 C1 by C1 plus C2. This V2 C1, this minus V2 C1 gets cancelled. Then you will get V1 C1 plus V2 C2 by C1 plus C2. This is Vc2 infinity. So here we can observe both Vc1 infinity equal to V1 C1 plus V2 C2 by C1 plus C2. Right here. Same Vc2 infinity also same V1 C1 plus V2 C2 by C1 plus C2. That is, at steady state, these voltages of Vc2 infinity and Vc1 infinity are equal. Okay, at steady state. Vc1 infinity equal to Vc2 infinity, that is initial voltage of V1 into C1 plus initial voltage of C2 into C2 by total capacitance. When these capacitors reaches equal voltages, then the steady state occurs and the current in the circuit is 0. R is 0. And you can write this equation. Suppose what happens if resistor is not there. Okay, here if resistor is not there, this is short circuited. That is, put R equal to 0 in the equations. That is, I have given generalized formula. Okay, the tau equal to R into C1 C2 by C1 plus C2. If R is 0, put R equal to 0 in this equation. If R equal to 0, tau equal to 0, then e power minus t by tau will become e power minus infinity, that is 0. This term will not be there. If this term will not be there, then you will get these values V1 C1 plus V2 C2 by C1 plus C2, which means if tau 0 means the time within 0 time it acquires steady state value, right? So that is what we have to observe here. That's it. All you need is remember the formula, and how to remember the formula also I told you. That way you have to remember. That's it. But please don't ignore this problem. To get this kind of problems, you have to be ready to tackle